All right, welcome back, ladies and gentlemen, to another astronomy and Q&A session with Mr. Mikulski. I decided to do session 2 a little bit differently. I'm going to still have my timer here going, but this time I'm going to use it as a stopwatch. I'm going to go ahead and count up, and I'm going to try to stick to that roughly 1 minute mark. But if you saw the first video, then you might notice that some of these might go a little bit long. So I'm just going to kind of be curious as to how long my answers are, but I'm going to try to stick to about a minute. But this way it's not beeping at me when I'm running out of time. All right, so questions from the first video were great. Let's continue on with the second one and see how these go. Question is asked by Fallen Angel. Okay, I like that name. How does retrograde affect people, children specifically? All right, well, if you're talking about astronomy, retrograde is used in two different kind of contexts. You either have retrograde rotation or you have like retrograde motion, which is kind of like a revolution thing. Retrograde rotation would simply be if Earth spins about its axis, a day on Earth, right? We spin what we say is east to west, okay? And so that's like how the sun rises and sets and things like that. Retrograde is like, for example, Venus rotates west to east, okay? So it goes the opposite direction. I don't know of any children or any other people that live on Venus, but I'll be totally honest, even if they did, I don't think that alone would have any effect on the people or the children of that planet or that object, okay? The other example of retrograde motion is if we were to look out at, let's say, I believe it is Mars, and where Mars is located on a certain time of day from one day to the next, okay? You would see that over time, Mars changes its position in the same way that like day after day, the sun is at a different height in the sky or different position in the sky because of our rotation and our motion around the sun. So those things combined get you what's called a retrograde motion, so that part of the orbit, if we watched Mars going across our sky, at some point it's going to appear to actually loop and go backwards and then start going forwards again. That backwards portion would be the retrograde motion. And again, there's actually nothing fancy happening there. It's just because when you look at two different sized circular or elliptical orbits of an inner planet and an outer planet, then the reference to each other is going to make it look like at some point one looks like it's going backwards compared to the other. But there really is nothing funny happening. They're both going normally. So unfortunately, to my knowledge, there's zero effect of these motions on people in any way, shape, or form. All right, 2 minutes. Let's go. Question number 2. How long has the universe been expanding? I can do this one super fast. Approximately 13.8 billion years. The universe has always been expanding as long as it has existed. And as far as we can tell, it's going to continue expanding. There's a couple of ideas, if you want to go deeper into that, that suggest that maybe one day the universe will get to a maximum expansion and actually start to collapse back in on itself. And that would be called like a rubber band idea or view of the future of the universe. But for right now, the universe is expanding, and in fact, it's even increasing in the rate at which it's expanding. And there's something called a Hubble constant to help explain that. Boom, under a minute. Okay, next one. Why does the sky change color based on the time of day and the weather? All right, well, the weather's an easy one. If there's a cloud in the sky, it's usually a whitish gray kind of color, and that depends on the moisture content primarily, because the water droplets in the sky, in the cloud, actually hinder the light. They prevent the light from going through it, and so that makes it basically a shadow. It's basically a dark or an absorption of light, and so therefore on the underside of it where we are looking up, we don't see the light coming through that cloud. Now, the other part, perhaps, is what more of your question is like, why is the sky blue versus why is it orangish and reds at the extents of our view in the morning or in the evening. So the sky is blue because of something called scattering. I believe Rayleigh scattering. I forget how to spell the guy's name. Rayleigh, something like that. I forget. Sir Walter Raleigh is the one who helped explain this. And the main idea is that light hits the particles of our atmosphere, and as it does, the white light, which has all the colors, tends to scatter different amounts at different frequencies. So blue lights tend to, if I remember correctly, they scatter further And so therefore, when the sun is more directly above us, then we get the blue skies. I think I might be saying that backwards, but either way. And then in the sunset, when the light has to go through more atmosphere to get us, because it's like if the ball of the Earth is a sphere and the atmosphere is some thick layer, as the light goes through that layer to get a further distance, kind of around the curvature of Earth, then the scattering light, only the reds and the yellows still make it through all that scattering. So then maybe it's the blue scatters less, the reds and yellows scatter more. That might be what it is. In either event, real quick fun fact, Mars, because of the materials made up in its atmosphere, actually has an opposite effect. So its daytime sky color is more reddish and orangish, and its sunrises and sunsets are more bluish. So fun fact for the day. All right. Thank you, Fallen Angel. I'm going to go ahead and move on to our next. Oh, we'll stop that video because we got that one all set. And we'll see what our next set of questions are. All right. We've got Juiced Grass over here asks, do you think that with an infinite amount of time, humans could explore nearly the entire universe? I think, oh, okay, hold on. I had a quick answer for this, and now I'm rethinking it. All right, my initial answer was going to be this. Yes, with an infinite amount of time, an infinite amount of things could be done. However, here's going to be my caveat. I'm going to actually disagree with myself because I think even given an infinite amount of time, meaning like the universe will still exist for an infinite amount of time, I don't believe that humans will exist for an infinite amount of time. I think we have a very finite life time in the sense of as a species. There's something about extinctions that I forget the details, but more or less the idea is this: the fact that a species does not go extinct is more the exception than the rule. The rule is that over a long enough period of time, everything will go extinct. And if you look back geological histories millions of years ago on the Earth, more things have gone exist than have not. And so that would apply to us as well, in my opinion. So from that standpoint, no, we cannot explore the whole universe. All right, next one. How long do you think it would take for humans to make space like Earth? I mean, like stores, homes, bars, things like that. Okay. Assuming we're talking about like you want to terraform the moon or Mars and you want to make like a shopping mall on Mars, I would say um, I would just throw it out there. I have no real evidence for this other than, again, my own random opinion. I would say like 100 years. I think 100 years we'd be able to do things like that. I would not say much anytime sooner than that. A couple of decades, we're still working on getting there, getting like life support systems set up, supplies back and forth, and being able to handle that. So I think that, yeah, that would take us probably about a good 100 years or more. All right. Could traveling while frozen be a norm eventually, like in Passengers? Ooh, I really like that movie. Um, and it's kind of like the scary part is like, yeah, what happens if you wake up too early? All right, spoiler alert. But anyways, the idea of that, like a cryogenic frozen state or a state of what do they call it, stasis, homeostasis, or suspended animation. There's a lot of different words that go along with that. If we could achieve that, that would definitely help us to travel those further distances. But like in that movie, or if you watch the movie Interstellar, or a lot of other space movies that actually have components of scientific fact in them, the problem becomes don't assume that you're going to have a round trip, right? Or if you do make a round trip, don't assume that anything that you left behind would still be there when you come back. So you really kind of have to plan that, like you and all of your resources, all of your friends, all of the other people and the genetic code that you want to bring with to procreate and make more people, all that's got to go with you on that trip because of the length of any trip that would require would be required for us to leave our solar system, especially is just so long that there's basically zero chance of you getting back, let alone being able to interact with anybody that you may have left behind. So I think that'd be cool. People, I think, with a lot of money have already put into time and effort, research into cryogenics and things like freezing your body just before you die in the hopes that maybe one day we'll find a cure for whatever was killing you. and we'll figure out a way to thaw you back out. But right now, that is my understanding, is that we know how to freeze things. We don't know how to recover them and keep them alive. So your cells get shredded when you freeze them because of the way ice forms, like icicles, right? They're like sharp. Like every little snowflake, if you will, is actually a sharp shape, and so it literally bursts your red blood cells, and you become kind of like a big pile of mush, which is kind of the same idea. If you take a steak and you like freeze it and you thaw it too many times, it just becomes mushy and gross. And so the same would happen for your body, let alone the alive component is a whole other aspect we haven't figured out yet. All right, good questions from juiced grass. I like that. All right, let's see if I can get one more in here. I'm not sure how long this video is going to go, but we'll try and get another set of questions. All right, from Lily Rose. Lily Rose asks, where is the edge of the universe? All right, this is a really great question, and there's a couple different ways that this can be answered. The edge of the universe could be viewed as like, well, how far can we observe? So you could say the edge of the observable universe, and that is a certain distance away. And I believe that is the number that gives us somewhere around 70 billion light years. Oh my gosh, I could totally find this really quick, but I don't know that number off the top of my head. It is bigger than the 13.8 billion 13.8 billion years that the universe has existed. So, in other words, there has been an average of more than one light year per year expansion, if that makes sense, because a light year is a distance. So the universe has expanded greater than one light year of distance for every year that it has existed. Okay, so figure that one out. Now, the observable universe is what I started with. Now, there is something else beyond that called a photon sphere, and that, I believe that's the right name for it, is like how far we can see evidence of things. So we can't see them directly, but we can see like the remnants of the light from those things, and that's actually beyond the observable universe, which is a crazy concept. There's a Veritasium video about this. It's a really good job, better than I can explain right now. But then there's actually like the actual universe, and for all purposes, the universe is infinite. All right, there's people, theoretical physicists and astronomers who work on the numbers and the equations to try to prove or confirm or disprove this idea. But from my understanding, I think that's still kind of the accepted view, is that the universe is pretty much infinite, but we don't have a way of like getting to an edge. Or think about this: if you said, "Where's the edge of the Earth?" Well, the Earth is basically a sphere, so there is no edge. You keep walking one way, you'll end up coming from the other way. Now, that could be one possibility for the universe. Maybe you keep traveling so far in one direction, you actually come back from the other direction. Or it's that same idea of the sphere, but actually being a sphere of infinite size, that you would never come back to where you started, but you could travel an infinite distance in one direction. And that would definitely be possible from our understandings. Cool. I love these questions. Question number 2 from Lily Rose. Why does the moon's gravity cause tides, but the sun's gravity doesn't? That's false. The sun's gravity does cause tides, but it's a more minor effect. And in fact, you get a more extreme high tide or low tide when the sun and moon are in a certain alignment relative to each other. So that way they are both acting in the same way versus canceling out that motion. However, the sun is a lot further away. So while the sun has much more mass than the moon, and so therefore has a greater gravitational pull on Earth in general, the moon being closer has a greater effect on those tides. So in the end, the sun and the moon do both cause tides. They both affect the tides. The moon just affects them much greater. All right. If there's a different life form that's light years away, could sound reach them? Absolutely not. There is no way that sound is going to get to them, because the empty vacuum of space does not allow sound to travel. So sound is a type of a wave. It's considered a mechanical wave, so it requires a medium or a substance for which it to travel through. And kind of the definition of space is that it's an empty vacuum. It's missing the particles, the stuff. Even our space around us here on Earth, there's air, there's atmosphere. That is still full of particles. They're gases, but it's still full. All right? We live at the bottom of an ocean of air. Okay. However, you go beyond that air and you get into the outer space, literally outer space, okay, because you're off of our Earth, and you don't have that same way of transferring sound. So there's a fun, I think it's a movie called Aliens. It came out in like maybe the 80s or so. But there's like the subtitle to the movie, or the subtitle is that in space, no one can hear you scream. So good, scary movies made from things like that. All right, we're going to stop with that one right now, and keep the questions coming. I will see you guys in the next video.